Here we are. We're moving on to Unit 4, Forces. The essential question for this lesson is, how do forces affect motion? Whoops. The standard that we'll be looking at is S8P3. Obtain, evaluate, and communicate information about cause and effect relationships between force, mass, and the motion of objects. Like all our lessons, it starts out with an engage your brain section to kind of spark you into thinking about forces. So your first question asks you to draw a diagram showing how force acts on a ball tossed up into the air. So if you toss a ball up into the air, you're exerting a force. You're exerting a force upward. At the same time, gravity is pulling on the ball downward. And so you produce an upward force while the gravity of Earth pulls on the tennis ball or the ball you threw up in the air downwards by gravity. There's a point, as we learned when we talked about kinetic and potential energy, in which the ball actually stops its motion. And that's where potential energy is going to be the highest. And then as it's following down to Earth, it's also accelerating due to gravity. The next question, number 2, asks you to write a caption for this photo. And it's got a photo of a person kicking a soccer ball. So you should put something that talks about how when the person kicks the soccer ball, they're adding a force. And that force is going to cause the ball to go, whoops, press the wrong buttons. Sorry. That force is going to cause the ball to go into motion. So the foot applies a force, and that force is going to cause the soccer ball to move. The next question asks you to apply, and this is an active reading question. So the first example they give you for context clues is the fisherman scooped his catch out of the water with a net. And so you got to think about the definition of net in this sentence. And so you're going to describe what a fishing net is. The next sentence says, subtract the mass of the container from the total mass of the substance of the container to determine the net mass of the substance. So you're going to take the total mass. Oh my goodness. So the total mass minus the container and that's going to give you the net mass of the substance. So you've got to kind of define it in these terms instead of a fishing net. The first part of the lesson is called a tour de forces. And the essential question is, what is a force and how does a force act on an object? Okay. So force is defined as a push or a pull. So in the top, why, Microsoft. In the top graphic, you have the stick guy pulling a box across the floor. And in the bottom example, you have the stick guy pushing the item across the floor. So force is a push or a pull. When you threw the ball up in the air in our first example, you were pushing it up and gravity was pulling. The equation for force is force equals mass. Remember that mass is measured in kilograms and the units for acceleration are meters per second squared. And that acceleration is the change in velocity. Remember we talked about, I don't know why I did that, but okay. Change in velocity. Okay, it just erased everything. Okay. And that velocity is speed plus direction. Okay, here we go again. Okay. And we know that speed is distance per amount of time. Okay, so F equals ma. If you're familiar with the formula triangle, you know, you know that whatever you need to solve for, you can use the triangle for. So if you are given the force and the acceleration, you can solve for mass. And you just look at the triangle. Force divided by acceleration equals the mass. Another way of looking at the triangle, it just tells you how to break down each one of the steps. So a force can cause an object to change its speed or direction. And we know if either one of those are changed, that we're changing the velocity. And we have a vocabulary word that means the change in velocity, and that is acceleration. Remember that acceleration is the change in velocity. So we can, I'll learn all this stuff soon, I hope. So to change velocity, we can speed up, slow down, or change direction. So 3 ways to accelerate. So some examples of forces that we'll be talking about. So hopefully you've had some time to look over those forces. So we talked about vectors a little bit when we talked about velocity and acceleration. So here we're going to talk about vectors again. Force always has a size and a direction. So the size of the arrow is going to tell you the magnitude of the force. So the bigger the arrow, the stronger the force. It also tells you what direction the force is going to be going in. So if we have these two examples, A and B, we would know that they are both going to the right and that A is a stronger force than B. And remember that a force is a push or a pull. So forces can be applied to objects without actual contact with the objects. So here you have the electrostatic force. They statically charged the balloon, and then the balloon's static electricity pulled the water. And so they are not actually touching, but the static electricity on the balloon is affecting the water. So force can be applied without two objects touching. Same thing with this image. We have a magnetic force that is levitating the crystal and turning the crystal. And in this one, we have the sun, which has supermassive gravity, and we can see it pull in a comet. So the gravity of the sun is changing the motion of the comet. And that takes us to number 5. Number 5 is an active reading, and it asks you to, as you read this page and the next, underline the unit that is used to express force. So the unit that is used to express force is a Newton. We represent it with a capital N. And if we break it down into its units, it's kilograms per meters per second squared. As you go into high school, you'll be breaking down some of these formulas and units, and so it's always good to know what they break down into. So here's another breakdown, and it shows you what you should underline. So we have force in newtons, and force equals the mass times acceleration. So remember on the last slide I said force equals kilograms per meters per second squared. So we have mass times acceleration. Another view of this. And that brings us to number 6. Number 6 says draw arrows to represent the pushing forces in the image at the left and the pulling forces in the image at the right. So the left is the karate guy breaking the wood in half. And so we know that there's a large amount of energy coming from his hand. And we know that since the wood breaks, there's a smaller amount coming from the wood. In the picture on the right, you have the dog pulling and the lady pulling, and they're equal. Okay, so we just did this. A little line. Ah. So these are equal. Okay, number 7. The arrows in the picture below represent contact and distance forces. Label each arrow with a C if it is a contact force or D if it is a distance force. Well, we know right away that the bird and the plane aren't touching anything, so that has to be a distance force. And that force is the force of gravity. The man is touching the lawnmower and touching the ground, so we know that both of those are contact forces. Contact force because his feet are touching. Contact force because he's touching the lawnmower. Oops. And we said already this is distance and this is distance. And that is the end of this one.